Alright, welcome class. Today we're going to delve down into the black hole, that's what this picture is supposed to represent, of long division. And we're going to split this lesson up into two different days and two different videos. So this is part A. This is just on the division algorithms. We're going to review the old partial quotients algorithm. We're going to talk about the limitations and why it's important for you to switch to the more traditional parent does McDonald's sell cheeseburger way. So why don't we go ahead and dive right into this, and let's review partial quotient division one last time. Now in partial quotients division, we'll take a problem like maybe 1,000 divided by 8. Okay, and whenever I set up a division problem, whichever method I use, to set it up as a long division problem, I need to go ahead and switch the quotient in the numerator. The number 1,000 is the one being divided. It's the thing that goes under the division sign. And the divided by 8, that's what I'm dividing it in by, so that number actually goes out front. Okay, now that said, in partial quotients, we then go ahead and draw a vertical line along the right side. Okay, and partial quotients is just that. You don't have to figure out exactly how many times 8 goes into 1,000. You can kind of do partial little pieces at a time. So, for instance, I know that 8 goes into 1,000 at least 100 times, because 8 times 100 gives me 800. So I go ahead and I put my approximation of 100 over here, and I do 8 times 100, and that gives me 800. I then subtract that from my my number that is being divided, okay, and that leaves me with a remainder of 200. Now I ask myself, well, how many times does 8 go into 200? Well, without thinking too hard, I can go ahead and say it goes in 10 times, and 8 times 10 is 80, and if I subtract 80 from 200, I get 120. Alright, let's take another 10 out. So that's going to be another 80, and subtract it out, and that leaves me with 40, and now I can probably finish this up. 8 goes into 40 exactly 5 times. 8 times 5 is going to be 40. I'm running out of room here at the bottom, but if I subtract, I finally get a remainder of 0. I'll have to put it up here. Okay. Alright, so that's partial quotients division. And now, to finish this problem, all I need to do is add up this column, 100 plus 10 plus 10 plus 5, and I did a pretty good job of lining it up. So let's line up the ones digits. 0, 0, 0, and 5 gives me 5. 0, 1, and 1 gives me 2. And then the 1 gives me 125. Now I can circle it right here, or better yet, put that answer up here on top. 125 is the answer. Okay, so that's partial quotients division. Okay. Whoops. Sorry about all that. Ignore that little bit of writing. All right. So let's take another problem like 220 divided by 9. Okay. Again, I crisscross, and I get 220 divided by 9. I'm going to go ahead. Oops. Okay, I'm going to go ahead and I'm going to draw in my vertical line. And I've got a little less room here, but let's go ahead and squeeze it in. I know that 9 goes into 220 how many times? Well, I'm going to start with 20. Okay, 9 times 20 is 180. And I'm going to go ahead and subtract that. And when I do, I get a remainder of 40. All right, now how many times does 9 go into 40? Well, I know that 9 goes into 40 4 times, because 4 times 9 is 36. So let's take that out. And now I'm left with just a 4. Okay, now this 4 is a remainder, so there's a couple things I can do. First, let's go ahead and add up what we've taken out so far, which is 24. And so the answer is 24 with a remainder of 4 is one way you can write it. Or I could write that as 24 and 4. You take that remainder and put it over the 9. So I could write it as, let's see, I'll put it up here, 24 and 4/9. And again, if all you want is an integer answer or a remainder or a fraction answer, no problem using partial quotients. Alright, so that's a review of how we used to divide. And if you have been a person that divides like this is fine for simple arithmetic. But as we move forward into more complicated decimal division, you're going to have to learn the other algorithm as well. Alright, sorry, I got a little choked up there. Alright, let's continue on. All right, so now let's look at that first problem, the 1,000 divided by 8, and let's do it the traditional, I don't know why that says T, that should be an L, the traditional, or you might call this your parents' way, your teacher's way, and you might also know it as the Does McDonald's Sell Cheeseburgers way. And that's an acronym like PEMDAS, DMSCB, and what it actually stands for is divide, multiply, subtract, check, and then bring down. Okay? And that is the more traditional algorithm. So again, it's divide, that's the first step, then you multiply, then you subtract. And actually those three steps are very similar to what you do in partial quotients. The only difference is in partial quotients you just take a little bit out at a time and it doesn't matter whether you get it all out. When you do the divide step in the traditional method, whatever step you're on, you have to take as many out as you can. And we'll see that in just a second. The C actually is in a different color up above because that stands for check. You don't write anything down when you check. You just make sure you didn't make a mistake. And then you bring down the next digit, which is how we continue the problem. And then we just go back to the beginning, and we just keep repeating these steps like a loop, going around and around and around until we get the answer. All right, well, let's take again the problem of 1,000 divided by 8, and let's do it the traditional algorithm this time instead. Okay, so again, we do the little crisscross. We put the 1,000 underneath the divide sign. We put the 8 out front. Now, we start from the left and we go right as we do the problem. So we first ask ourselves, how many times does 8 go into 1? All right, well, 8 doesn't go into 1. Okay, 1 would go in 8, but 8 doesn't fit in a 1. So we could put a 0 on top and just continue to the next step, or better yet, just let's skip to the next step. So how many times does 8 go into 10? Well, 8 goes into 10 one time. And now that's the divide step. Now let's multiply 1 times 8. Well, 1 times 8 is easy, that's 8. And then let's subtract. 10 minus 8 is 2. Okay, now the check is just make sure I took enough out. So 2 is less than 8, so I couldn't have taken another 8 out, so I did it right. And now I bring down the next digit, which in this case happens to be a 0. And I start the process all over again. I go back to the top, and I divide, and I'm going to switch to yellow this time. 8 goes into 20, a total of 2 times. And 8 times 2 gives me 16, and I subtract, and this time I get 4, which is also less than 8. So I bring down the next digit, which is a 0. And the last step, we'll go to white. Okay, 8 goes into 40 5 times, and 8 times 5 is 40, and I subtract and I get 0. Okay, and again I get the same answer I got before, 125. Okay, there's no multiple steps, and as you see, we'll see in a second, there's another advantage of this in case I needed to continue the problem. Okay, so this is the traditional method of division. This is the way your parents really want you to divide because this is the way they learned back when they were your age in 6th grade. And while I do really like the lattice method for multiplying, the new way to do that, the newer ways to divide work up until about 6th grade. But once we get into decimals, those methods don't work on certain types of problems. So you have to know this way one way or another. So it's probably just a good method to get familiar with. Alright, so now if we're going to get familiar with it, let's go ahead and practice another one. So let's go ahead and we'll go to the next screen and let's take a problem like 217 divided by 4. Okay? Alright, again we reverse them. We put the 217 underneath, we put the 4 out front. Okay? And it's always a good idea, it's always a good idea to write down the Does McDonald's Sell Cheeseburgers. So I'm just going to write the letters down. Does McDonald's sell cheeseburgers? Okay? And make sure you write cheeseburgers 2 letters, C and then B. Alright, let's follow that step by step and let's just go right across and let's divide this quotient. So 4 doesn't go into 2 because it's too small. So the first place it'll go in is 21. 4 goes into 21. Now let's stop and think about your math facts. A lot of times, by the way, people say they don't like division. It's really because they have trouble with their math facts. So you've got to be a good multiplier to be able to divide. So 4 goes into 21 how many times? And if you know your math facts, you know it goes in 5 times because 4 times 5 is 20. That's the divide and the multiply step. Next we subtract. We get 1, We check that that's less than 4. It is, and so I go ahead and I bring down the next digit, which is 7. The next step says 4 goes into 17 how many times? And the answer is 4 times. 4 times 4 is 16. So when I subtract that, I again get a remainder of 1. Now here is where the traditional method outshines the partial quotients. If you're doing this problem with partial quotients, you could say 54 and a remainder of 1, or you could say 54 and 1/4. But what we're able to do is we're able to put a decimal point at the end of the 7, and we're able to add another 0. And we can continue the problem. So we were at the check step, 1 is less than 4, let's go ahead and bring this 0 down. Now, since I put a decimal in, I've got to put a decimal up on top too. Okay, let's make those decimals a little easier to see. But other than that, I just ignore the decimal point and I just keep dividing. So how many times does 4 go into 10? Well, it goes in, see, we haven't used yellow yet. It goes in twice, because 4 times 2 is equal to 8, and if I subtract, I get a 2. Well, I'm still not done, so let's go add another 0 and bring it down, and be very careful that you keep everything nice and lined up. Finally, to finish this problem, I ask myself, 4 goes into 20 how many times? So I divide, I get 5, I multiply, I get 20, I subtract, and now I get what I call a happy 0 because there's no remainder left. And so the answer is 54.25. And I get an exact decimal answer by being able to continue that division over 2 more places and getting the decimal. Now we'll talk a lot more about decimal division tomorrow. Okay? But this, I wanted you to see this problem because this is an advantage of doing the traditional division algorithm. Okay, I don't want to make this to be a long video, so let's go ahead and do one more. Let's take 22 and divide by 12. And I want to show you something else neat that happens and how this method is really helpful. Now, oops. Okay, let's back up. All right, and so again, we're going to go ahead and we're going to put the 22 underneath the division sign, and we're going to put the 12 out front. Okay, we're dividing by a little bigger number, so the math is going to be a little bit harder this time. So again, does McDonald's sell cheeseburgers? Divide, multiply, subtract, check, bring down. All right, let's get started. So 12 goes into 22. Well, this is a little harder. If I did 12 times 2, I'd get 24. That's too big, so I'm going to have to stop at just 1. Now that's easy to multiply because 12 times 1 is 12. It's also pretty easy to subtract. I'm going to get a 0 and a 1. I get 10. And 10 is not much smaller than 12, but it is smaller, so the check works. I next bring down a digit. Again, I don't have any digits, so I'm going to add an extra 0 and extend the line over a little bit, and I can bring it down. So now I ask myself, how many times does 12 go into 100? Again, this is a little more work. This is where your multiplication facts are actually going to get really tested. Okay? Now you might not know for sure, so you might come over here and practice. Let's say, I don't know, maybe it goes in 7 times. So 12 times 7 is 14, and I get 84. Well, that's not really close to 100, so now let's times 12 times 8. Well, 12 times 8, 8 times 2 gives me 16, carry a 1. I actually get 96. That's pretty close to 100, so the answer is going to be 8. So I divide 12 into 100, and it's going to go in 8 times. Now I don't have to multiply because I already did the work. I can go ahead and just put that in here, and I subtract, and I get a 4. Okay? Well, I'm not done yet, am I? Nope. So let's add, I'm going to change colors here. I'm going to add another 0, bring it down. How many times does 12 go into 40? That one's a little easier. 12 times 3 would give me 36. So divide, multiply, subtract, and I get 4. Well, that seems familiar. Didn't I just get 4 for the remainder last time? Let's try another step. Let's put another 0 in and bring it down. And I'm doing, wait a second, that's the same thing. 12 goes into 40, again, 3 times, and I'm going to get 36 again, and this is going to keep happening, isn't it? There's no way I'm going to break out of this loop. Well, that's oops, I forgot my decimal point right there. That's exactly what I wanted you to see. All right, so at this point, we can see that these 3's are just going to keep going on forever as long as I continue this problem. So what we've just found is our first repeating decimal division problem. So the answer to this one comes out to be 1.8, oops, sorry, that's supposed to be an 8, 3, 3, 3, 3, 3, 3, 3, and eventually you're going to run out of room going off the screen. Well, that's not very convenient. So what we're going to do is another way to write that is 1.83, and after that 3, it's just going to keep repeating 3's. So we put a little bar on top, and that means it's a repeating decimal. So this means those 3's go on to infinity. 1.833333333333, and it'll never ever stop. Okay? So that is the traditional does McDonald's sell cheeseburger traditional approach to division, and we will continue this discussion tomorrow. So tomorrow in class, we'll practice doing some divisions only with this traditional algorithm, and we'll start with some simpler problems, and we'll build up to more complicated ones like this. We'll then continue that in tomorrow night's flip video, and we'll practice another day in class. So that's it for tonight. I've gone for 15 minutes. If you need to back up and kind of watch over this, or maybe even practice one of these yourselves, that would be great. Otherwise, I will see you in class tomorrow. Good night.